If you could fly 2 billion miles in the direction of the Pegasus constellation, and knew where to look, you would find a thin, flat object, about the size of a football field and up to 10 times more reflective than the average comet. If you watched it for a while, you would notice that it is tumbling as it moves away from the Sun, turning end over end roughly every 7 hours. This object passed the Earth in October 2017. As it began its return to interstellar space, the Canadian astronomer Robert Weryk identified it among the images from what was then the world's most powerful camera, a telescope in Hawaii called Pan-STARRS-1. The astronomers in Hawaii called it Oumuamua, a Hawaiian word meaning first scout from a distant place. Oumuamua was the subject of great excitement. It was the first object humans have observed traveling through the solar system from interstellar space. But it also became controversial. Its shape, the way in which it approached us, and the way it moved away are not consistent with the behavior of an asteroid or comet. For 11 days, the world's telescopes searched for meaning from this strange visitor. A year later, the debate about Oumuamua intensified when one of the world's foremost astronomers, Avi Loeb, submitted a paper to the astrophysical journal Letters. In it, Loeb and his colleague, Shmuel Bailey, argued that Oumuamua's strange properties indicated that it was a new class of thin interstellar material, either produced naturally, through a yet unknown process, or of an artificial origin. Since then, Loeb has maintained that the most rational, conservative explanation is that Oumuamua was produced by an alien civilization. We will almost certainly never see Oumuamua again, because it is heading away from the solar system at 30 kilometers a second. But Loeb says scientists must prepare now for what happens when the next such object arrives, as he believes it will very soon. If he is right, these objects surround us in numbers that are almost unimaginable. Avi Loeb is a fast talker. He has the rapid fluency of someone who has spent decades giving lectures, but there is also an unpracticed enthusiasm to his speech. He keeps the accent of his native Israel, though he has lived in the US since 1988, when he took a fellowship at Princeton University. His first interview was with the famous physicist Freeman Dyson, who was also well known for theorizing about alien civilizations. Loeb spent almost a decade as chair of Harvard's astronomy department, the longest any scientist has held that position. He has made or helped to make a number of major breakthroughs in our understanding of the universe, including different ways of detecting exoplanets, planets orbiting stars other than the Sun. He has correctly predicted incredible phenomena, such as stars that streak across the depths between galaxies at nearly 500 million miles an hour. He is the founding director of Harvard's Black Hole Initiative, part of the Event Horizon Telescope project that in April 2019 presented to the world the first photograph of a black hole. Practically all of Loeb's predictions have had the backing of his peers, except one. In the autumn of 2019, Loeb and a colleague, a senior astronomer at Harvard, attended a seminar on Oumuamua. After it ended, Loeb told me, I left the room together with a colleague of mine who is a conservative, mainstream astronomer, and he said, this object is so weird, I wish it never existed. This is, Loeb says, a terrible thing to say for a scientist. You should accept with open arms anything that nature gives you. But he has also found such attitudes to be common. There is, he says, a widespread taboo on talking about extraterrestrial intelligence. Why does Loeb believe that Oumuamua was alien technology? First, unlike most things in space, Oumuamua was not moving relative to what astronomers call the local standard of rest. Loeb calls this a very special frame of reference, sort of the galactic parking lot. It was not that Oumuamua visited us but that the Sun and its attendant planets, moving through space at 450,000 miles an hour, move past it. The Sun's gravity bumping it as a ship's wake disturbs a piece of flotsam, but what really excites Loeb is what happened next. Oumuamua showed an excess push away from the Sun, in addition to the Sun's gravitational force acting on it. This happens with comets, which can speed up as the frozen material on them vaporizes, causing them to swerve through space and producing a distinctive tail. Based on the change in its speed, Loeb says Oumuamua would have had to lose about a tenth of its mass. That's quite a lot. We should have seen a very clear cloud of gas around it. But Oumuamua had no tail. Close observation by the Spitzer Space Telescope saw nothing around it. It did not even radiate any heat. And it did not move erratically, as comets do, but accelerated smoothly away from the Sun. The most rational explanation for this, Loeb says, is that it was pushed by sunlight itself. Oumuamua's shape is also distinct from almost everything else we have observed in space. Its brightness varied by a factor of 10 every 8 hours, suggesting a very extreme geometry. The most popular depiction of Oumuamua is of a long, cigar-shaped rock, but research by Sergei Mashenko, a computational astrophysicist at McMaster University in Canada, suggests a 91% chance that it is disc-shaped. Each of these factors is highly unlikely for any astronomical object. Taken together, Loeb says, they make Oumuamua a very rare object, if it's coming from the same reservoir of objects, asteroids and comets, that we are familiar with. For Loeb, the rational answer is to find something that fits the data and is familiar to us. Astronomers were able to do this in September, when another object, called 2020 SO, was discovered in orbit around the Earth. Just like Oumuamua, 2020 SO appeared to have been pushed from its gravitational course by sunlight. And this time, NASA confirmed that 2020 SO was artificial. It was a piece of a Centaur rocket, launched from Florida in 1966, that had been recaptured by the Earth's gravity. For Loeb, 2020 SO illustrates the fact that we can identify an object that behaves in a peculiar fashion, that has no cometary tail, and yet it exhibits an extra push. And if Oumuamua, indeed, was that kind of an object, the question is, who produced it? Loeb's biggest concern about Oumuamua is not that it has disappeared from sight, but that the response to it betrays the culture of science. The Copernican principle, the change in thinking that allowed humanity to begin modern astronomy, states that we are not at the center of the universe. To pretend, in the face of confounding data, that Oumuamua is just another asteroid is to act as if we are. Loeb's sense of scale and probability is informed by a long study of the early universe. In a 2014 paper, he described the likelihood that rocky planets with liquid water provided the chemistry to support life when the universe was as little as 10 million years old. In the 13.8 billion years since that time, billions of galaxies, each home to billions of Earth-like planets, have formed. To say that life, intelligence and civilization have emerged only once in such an expanse of time and space is, he argues, a radical view. See also, how Chinese novelists are reimagining science fiction. There is nothing more conservative than saying that if you arrange for the same circumstances, you get the same outcome, he says. For Loeb, the conservative assumption about humanity is that we are a middle-of-the-road kind of life that exists everywhere. I don't think that we are special or unique. But if we are not unique, it follows that Oumuamua is not unique either. Pan-STARRS began searching for near-Earth objects in early 2014, and discovered Oumuamua in under 4 years. Applying the Copernican principle, we should assume that we will see another object once every 3 or 4 years. But this frequency may change, because our ability to see them is about to increase. This year, the telescope at the Vera C. Rubin Observatory in Chile will take its first test pictures. Astronomers call this first light of the night sky. Even more powerful than Pan-STARRS, this will repeatedly photograph everything visible in the sky using a mirror more than 8 meters across and the biggest digital camera in the world. We could then find one such object every month, says Loeb, because, there should be many more out there. The question of how many Oumuamuas are out there is the point at which the inferences become dizzying. If we see one every few years, Loeb infers that there should be one in every volume roughly the size of the orbit of the Earth around the Sun. This is a vast area in human terms, but in the immensity of space, it's pretty small. So it means that there are plenty of them, a quadrillion of them, inside the Oort cloud. Inside the solar system. There are lots of them. It is difficult to reconcile the idea that we are surrounded by trillions of pieces of alien technology with scientific conservatism. Humanity's understanding of itself would be radically changed if we knew that other life had once built such things, but Loeb believes, as he explains in his compelling and personal new book on Oumuamua, Extraterrestrial, the first sign of intelligent life beyond Earth, that humanity's understanding of itself should change now. The book is not so much a claim for one object as an argument for a more open-minded approach to science, a combination of humility and wonder that he worries has been supplanted by elitism and intellectual gymnastics. The crime here, he tells me, is that a whole branch of astronomy, a subject that is so appealing to the public, that the scientific community can address with its instruments and methodology, is not being addressed at all. But if Loeb is right, we may soon have no choice but to wonder. Next month, on the 18th of February, the Perseverance rover will land on Mars to search for signs of life. Any evidence, even of ancient microbes, on our celestial neighbor would suggest that life is far more abundant than is generally accepted. We might learn much more in the coming year, says Loeb. If you liked this video, please give us a thumbs up and subscribe. Please hit the bell icon so you will be notified of new videos.